Bugs, they're everywhere. We've all been there. You're cruising along, coding up a storm, feeling like a rock star developer. Then, bam! A bug hits you right between the eyes. Your code crashes and burns, and you're left scratching your head, wondering where it all went wrong. Bugs are an inevitable part of software development, and they can lurk in the shadows of even the most carefully crafted code. But fear not, fellow developers. There's a powerful weapon in our arsenal to combat these pesky bugs: database unit testing. In the realm of databases, where data integrity is paramount, unit testing becomes even more critical. A single bug in your SQL Server database can have far-reaching consequences, leading to data corruption, inaccurate reporting, and even system downtime. But with database unit testing, you can catch these bugs early on, before they wreak havoc on your production environment. So buckle up, and let's dive into the world of database unit testing for SQL Server. Database unit testing is like shining a bright light on every nook and cranny of your SQL Server code, ensuring that each piece works flawlessly in isolation. Imagine this. You've written a stored procedure that calculates the total sales for a given month. With database unit testing, you can create a series of tests that execute this stored procedure with different inputs, verifying that it returns the correct output every single time. These tests act as automated guards, ensuring that your database code behaves as expected. By breaking down your database code into smaller, testable units, you can identify and fix bugs quickly and efficiently. This not only saves you time and money in the long run, but also gives you the confidence to make changes to your codebase without fear of introducing new bugs. Find bugs early. Save time and money. Picture this. You're working on a large-scale SQL Server project, and you've just spent weeks developing a complex stored procedure. You deploy it to production, feeling confident and proud of your work. But then, disaster strikes. The stored procedure contains a critical bug that brings down the entire system. Ouch! This is where unit testing comes to the rescue. By testing your code in isolation, you can catch these bugs early in the development cycle, before they have a chance to impact your users or your bottom line. Think of it like this. Fixing a bug during the development phase is like replacing a loose screw on a bicycle. Fixing it in production is like trying to rebuild the entire engine while the bike is speeding down a hill. Unit testing isn't just about finding bugs, it's about building better software overall. When you embrace unit testing, you unlock a treasure trove of benefits that will transform your development process. Improved code. Quality. Unit tests act as a safety net, ensuring that your code behaves as expected. Faster development cycles. By catching bugs early, you avoid time-consuming debugging sessions later on. Reduced costs. Bugs found and fixed early in the development cycle are significantly cheaper to resolve. Increased confidence. With a comprehensive suite of unit tests, you can make changes to your codebase with confidence, knowing that your tests will catch any regressions. Better collaboration. Unit tests serve as living documentation, making it easier for developers to understand and maintain the codebase. Section 5. Getting started with database unit testing. Your first steps. Ready to dive into the world of database unit testing? Well, here's a step-by-step guide to get you started. First, choose a framework. There are several frameworks available for SQL Server database unit testing, but one popular choice is tSQLt. Don't worry, we'll delve into tSQLt in more detail later on. Next, install and configure. Once you've chosen a framework, you'll need to install and configure it for your SQL Server instance. Then, write your first test. Start by testing a simple stored procedure. Use your chosen framework to create a test case that executes the stored procedure with specific inputs and verifies the output. Now, run your test. Most frameworks provide a way to run your tests and view the results. You should see a clear indication of whether your test passed or failed. Finally, repeat and refine. As you add more functionality to your database, continue writing unit tests to cover the new code. Section 6. Best practices for effective unit testing. Write better tests, faster. Writing effective unit tests is crucial for reaping the full benefits of database unit testing. Here are some best practices to keep in mind. Keep it simple. Each test should focus on a single aspect of your code. Avoid testing multiple things in a single test. Use meaningful names. Choose descriptive names for your tests and test cases. This will make it easier to understand what each test is doing. Test for both success and failure. Don't just test for the happy path. Make sure to test for edge cases and error conditions as well. Avoid test dependencies. Each test should be independent of other tests. This will make your tests more reliable and easier to maintain. Automate your tests. Integrate your unit tests into your continuous integration and continuous deployment (CI/CD) pipeline to automate the testing process. Section 7. Introducing tSQLt, your secret weapon for database unit testing. tSQLt is a powerful, open-source framework specifically designed for unit testing tSQL code in SQL Server. It's like having a dedicated testing lab built right into your database. tSQLt provides a comprehensive set of features that make it easy to write, organize, and run unit tests. Here are some of the key features of tSQLt isolation. tSQLt uses transactions and database snapshots to isolate each test, ensuring that your tests don't interfere with each other or with your production data. Assertions. tSQLt provides a rich set of assertion functions that you can use to verify the expected outcomes of your code. Test setup and teardown. tSQLt allows you to define setup and teardown procedures that will be executed before and after each test, ensuring that your test environment is clean and consistent. Fake tables. With tSQLt, you can create fake tables that mimic the behavior of your real tables, allowing you to test your code without affecting your production data. Mocking. tSQLt enables you to mock the behavior of external dependencies, such as stored procedures or functions, giving you more control over your test environment. Section 8. Real-world example. tSQLt in action. Let's say you have a stored procedure that calculates the total sales for a given month. With tSQLt, you can create a test case that sets up a test environment with sample sales data, executes the stored procedure, and verifies the calculated total sales. Create a test class for the sales calculation stored procedure. Create assembly tSQLt from C to program files x86 tSQLt tSQLt with permission set or unsafe. Go exec tSQLt. New test class, sales calculation tests. Joe, create a test case to verify the total sales calculation. Exec tSQLt, run sales calculation tests. Test that sales are calculated correctly. Go. This test case clearly defines the expected behavior of the stored procedure and provides a way to automatically verify its correctness. Section 9. Conclusion. Embrace unit testing. Build better databases. In the ever-evolving world of software development, where agility and quality are paramount, database unit testing is no longer a luxury, it's a necessity. By embracing unit testing as an integral part of your development workflow, you can ensure that your SQL Server databases are robust, reliable, and built to last. So, take the plunge today. Explore the world of tSQLt and experience the transformative power of database unit testing for yourself. Your future self and your users will thank you for it.